And still, Matthew wavered. Bystanders gathered and seemed to grow agitated. It appeared as if rescue crews weren't doing anything and there wasn't a rescue boat in sight. Suddenly, Matthew jumped. That's when medical student and former lifeguard Garrett Cuppels made a daring split-second decision to go in after him without any rescue equipment. Garrett scanned the shore for rescue workers as he screamed for help.
I need a rig!
Stephen and Garrett towed Matthew to shore, where they expected rescue workers to be waiting with resuscitation equipment. It was then that officials appeared to start scrambling.
Someone get down here, please! Someone get down here!
This is war.
And you never pass judgment on someone, whether they're troubled and they'd like to, hurt themselves. Your job is really not to pass that judgment. That's for somebody else, and your job is to do what you're trained to do to help. And that's what I believe.
Hi, I'm Mike Conrath from the Standing Paraplegic OR Device Group. We're a team of 5 senior biomedical engineering students from the University of Wisconsin-Madison, led by Professor Amit Nimankar. Last fall, we heard about Dr. Cuppels' story and we were captivated. We heard about his heroism and his tragedy, and ever since then, we've been determined to get him back into the operating room. That is why, over the last year, we have spent hundreds of hours designing the Standing Paraplegic Omni-directional transport, affectionately called SPOT.
I'm Justin Cacciatore, and my role for this entire project is to develop the circuitry, so basically how we're going to power the entire system.
I'm Brett Olson, and my focus is on the building of the base to keep Garrett stable while he's moving around the operating room.
I'm James Madison, and I'm in charge of the mecanum wheels and the base design of the device.
I'm Blake Marzella, and my role on the team is all the programming aspects.
So my part of the project is really important because it will allow Garrett to move in any direction at any moment quickly and accurately. I'm going to do this by using mecanum wheels, which are wheels that have small rotors built into them at 45-degree angles. And so by controlling these wheels independently, Dr. Cuppels will be able to move laterally, diagonally, frontward, backward, and side to side.
Dr. Cuppels will control the device using a joystick that was donated to us from CTI Electronics. And essentially this device will allow Dr. Cuppels to move any way along the table, whether it be forward or backwards or even translationally, just so he can move around the OR with minimal effort.
Many design teams use mecanum wheels in their robots, but there's no such device that enables a paraplegic to utilize mecanum wheels for precise and accurate movements.
The specific model we're using is designed to control 4 motors. So what we need to do with that is control all 4 motors completely independently so that they can run at different speeds, which will allow the mecanum wheels to move in different directions.
So basically we only need the raw materials and the parts to assemble to make the product. We already have the design, we have the tools to put the parts in the places they need to be so we can make this device for Dr. Cuppels.
I definitely think there's some pressure on this project. Essentially someone's livelihood hangs in the balance here. We've put a ton of time into this project. We think we have a really great design, and if we can't actually build that design, come up with a physical device, it's going to be a lot of hours wasted, and it'll be tough for Dr. Cuppels as well.
So this problem was brought to our attention by Dr. Jones, who is a surgeon at Berlin Memorial Hospital, and he'd like to assist Dr. Cuppels in returning to the operating room.
Dr. Cuppels is going to be able to help thousands of people if we can get him back in the operating room and he practices until he retires. If he does 6 operations a week, that's life-changing for those 6 people that he does the operations on. So if we can just get him back to the operating room, I think we've succeeded.
We're working for a real person, for one, who is actually trying to get their livelihood back. This isn't just a research tool, and it's not just to write a paper at the end of the day or leave it on the shelf. What we're making has to work.